Here's another system of linear equations, three equations with three variables, three unknowns. I want to try to find the ordered triple, if it exists, that is the solution to each of those linear equations. We're going to use again our addition elimination method. We're going to work with two of the equations at a time to eliminate a variable, work with another pair to eliminate the same variable. That will get us from a system of three equations with three unknowns to a system of two equations with two unknowns. We will eliminate one of those variables, which gets us to our linear equation with only one variable that we can get our numeric answer for, work our way back to find the values for the other two variables. Well, one thing I noticed right away when I look at this system, if I were to just add these two equations, equations 2 and 3, call this one equation 1, equation 2, equation 3. If I were to simply add those two equations together, wouldn't the y terms disappear? Because the coefficients there are additive opposites. One is plus 1, the other one is minus 1 for the coefficients. I can immediately create a new linear equation that only has the variables x and z. So let's go ahead and do that. 2x plus 3x would give us 5x. Plus y minus y, as we've said, disappears into 0. Plus z plus 2 more z is plus 3z. And 1 plus negative 5 is negative 4. So I now have created a new equation that only has x and z. I want to do that again. I want to work with a different pairing and create another equation that only has x and z. What if I take equation 3? I'm going to take equation 3 and multiply it by 2. I'm going to take 2 times equation 3. 2 times 3x will be 6x minus 2y plus 4z equals negative 10. Don't forget to multiply the constant by the same value. So I took every term of equation 3 and multiplied it by 2. And now let's add equation 1, which is x plus 2y minus z equals 8. And again, the y's disappear, so I have 6x plus 1x is 7x plus 3z equals negative 2. And now I have this new system of two equations with just the two unknowns x and z. So let's eliminate one of those variables. Well, how about if I take this equation and multiply every term by negative 1? That will make this coefficient minus 3z, and when I add it to plus 3z, the z's will disappear because those are additive opposites. So we'd have minus 5x minus 3z equals 4. When I multiply this equation by negative 1, and so now we have 2x equals 2, x equals 1. And we have the first of our solutions. The x value that is the part of the solution that solves every one of those equations is 1. Now let's take that value of x and use it to find our values of z and y. Of course, I want to take this value of x and put it into one of the equations where I only have x and z. So let's put it into that first equation. If x is 1, 5 times 1 is 5. 5 plus 3z equals negative 4. Subtracting 5 from both sides, and then dividing by 3, z equals negative 3. So now I know x is 1. I know z is negative 3. So let's put those into the first equation. If x is 1, that will become 1 plus 2y minus the z minus negative 3 is plus 3. 1 plus 3 is 4. Subtracting 4, I get 2y equals 4, or y equals 2. And the ordered triple solution is x is 1, y is 2, z is -3. And we have found that one value that is a solution to every one of those linear equations in 3 variables.